Hello, and welcome to today's webinar, the deep dive into the Typesafe Reactive platform with a focus on Akka and Scala, led today by Nilanjan and Raychaudhuri. My name is Laura Masterson, and I'm happy to be hosting the final of this three-part series. Previous presenters have included Jamie Allen and Kevin Weber. I know many of you have been asking about the recordings and the slides. We were going to be releasing all three of those as a set. They should be ready shortly once we wrap up editing for Nilanjan's session. We're also going to publish a short blog post highlighting some of the Q&As that people have submitted throughout the three presentations. So if you have questions throughout Nilanjan's session, just add those in the lower left-hand box on your screen, and we will save some for a Q&A with Nilanjan at the end, and we'll also make sure to include those in the blog. So while we wait for a few more folks to join, I just wanted to launch with a couple of polls so that we can get to know you all a little bit better. The first poll is, are you currently using the Typesafe Reactive platform? And I'm just going to leave this open for about a minute or so. Give folks a chance to answer. All right, I'm going to close that one, get to the next. Next question is, are you currently using Scala in production? All right, great. Skip over the results. And the final question is, are you currently using Akka in production? Okay, thanks for taking the time to fill those out. And with that, I'm going to hand things over to my colleague Nilanjan. Nilanjan, thanks for presenting today.
Thanks, Laura. Hello, everybody. So I've been working for Typesafe for more than 2 years now. I work with a professional services team where my job is to actually help work with clients, work with teams, help them building reactive application using Typesafe platform. So some of the motivation and the things that I'm going to talk about in this webinar are actually from the real world perspective. I'm going to share some ideas, knowledge, how people are actually building reactive application and how they are using Akka. This is the last part of the webinar series. So the first session kicked by Jamie, where Jamie introduced a reactive application in general. He talked about the characteristic of reactive application. And in the last one, Kevin kind of introduced Play Framework, how Play Framework and Activator in combination helps you to build reactive applications. So this part is going to be the last part of the deep dive series where we're going to focus on Scala and Akka. So I think it's safe to start with kind of an essence of reactive application. I'm not going to go too much of details about this because Jamie and Kevin have discussed this a lot, but I think it's a good idea to actually somehow recap this. So the general idea, the final value, the main idea behind reactive manifesto and reactive application is to build responsive application. Responsive. We want to build application where it's interactive, it's responsive to the customers because it's good for business. Now, to build a responsive app, you need to build on three other important characteristics that we have seen in the real world. We have realized that these three things are very important. Event-driven, so we need to have our design decoupled so that we can scale better. So scalability is another very important aspect of it because we want to react to load. We want to figure out what happens when more users comes in, how should we handle that. And at the same time, we need to also make our application resilient. So if things goes wrong, how can we handle that? And in this presentation, this webinar, I'll try to see how Akka and Typesafe Reactive Platform kind of helps you to build those things. Because if you think about it, if you want to build a responsive app, and if you don't have help or libraries or frameworks out there to help you to do that, it's a pretty hard problem. We want to rather have tools or building blocks that helps us with all these features so that we can focus on solving business problems. So what is Typesafe Reactive Platform? So Typesafe Reactive Platform, before we go there's one thing I do like to mention, speaking of timing. So today we released a new version of Reactive Manifesto. We call it Reactive Manifesto 2. Since it's an evolving document, which kind of makes sense, right? Because as we're building reactive application in real world, we are learning lots of things. So we made a couple of changes. For an example, we no longer call it event-driven anymore. We call it message-driven. The basic difference here is events have no specific destination. But once you change to message-driven, which actually makes more sense because when you are doing message-driven application, you know where you want to send that message. You have a specific destination. And instead of being scalable here, we changed that to elastic because that's the essence, that's the general idea. I want to make my application elastic so that I can use my resources effectively. So how Typesafe can help here? What is Typesafe Reactive Platform? So Typesafe Reactive Platform consists of Scala, Akka, and Play. Now Scala is a programming language. You must be wondering that why we are talking about programming language to build reactive application. Because it's our medium, right? And we think Scala is well suited for helping us building reactive application. So why is Scala well suited? So Scala has few interesting characteristics. First thing, it has lightweight syntax. What that means is that you can get more stuff done with less lines of code, no boilerplate. It reduces the boilerplate for you. At the same time, it combines object-oriented programming paradigm with functional programming paradigm. What that means to you as a developer is you have more tools in your toolbox. Your design space is much larger now. You don't always have to now select imperative object-oriented design. You can now reach out for functional designs as well. And at the same time, it has strong static typing. As we're building complex application, strong static typing is very helpful because it allows you to give faster feedback. So if you decide to use Scala to build your reactive application, here are a few benefits. First, it makes you responsive, right? Because you can achieve same task with writing less lines of code, and this code is much more maintainable. It is also scalable because Scala language and the libraries that comes with that ecosystem gives you necessary building blocks to build scalable concurrent applications so that you can use all the resources you have. And finally, as I was talking about, it's a better design space. You have a bigger design space, more tools in your toolbox. We also think functional programming is key for building reactive application. Now, why is that? So let's take it for an example. The functional programming encourages immutability. Okay? So if you have things immutable, that means you don't have to worry about change. The problem with change is somebody needs to coordinate that change. You need to have a coordinator. You need to have locks. You need to have a synchronization. You need to have a mutex. The problem with all this is, first of all, it's hard to build. And second, it affects your scalability. Whenever there is a change, whenever there is a contention, it affects your scalability. Next important thing that functional programming provides as a property, as a feature, is something called referential transparency. What that means is that when you write code, it helps you to reason about your code. It helps you to say, okay, I think my code works. And you need to have a programming language which allows you to do functional programming, allows you to provides you all this tool so that it can easily build reactive application. Now, next thing we're going to talk about is Akka. Obviously, this is why most of you are here, right? So what is Akka? We call Akka is a toolkit. Okay, we don't say it's framework. It's a toolkit for building concurrent, distributed, fault-tolerant application. I know it's quite a mouthful. For next 30 minutes, we're going to spend time just to understand what do I mean by that and learn how Scala helps us, or Akka helps us to do that. So we consider Akka as a core for building reactive applications. We think Akka is the enabler of reactive application. Why? Because it provides us building blocks, these individual entities that communicates with each other via messages. Because that's one of the core of reactive manifesto. Second, it allows us, it provides location transparency. That means I can easily scale my application. It also has a fault tolerance. That means if things goes wrong, it provides us tools, building blocks using which we can make our application resilient. I think it's a good time to take a look at a reference architecture so that we have some example. I think the best way to learn Akka is to look at some examples and see how that works. So this is our reference architecture. This is the one Jamie introduced in his first webinar session. So in this reference architecture, we have cluster of play servers, which forms our web tier. Okay, and then these play servers are backed by Akka routers, which essentially does all the heavy loading. And we have this classic example where when a request comes in, this router kind of takes that work and splits out to a worker so that we can scale easily. This is like a classic design that we see in the real world people use. Now, looking at the architecture, I think it will be very helpful if we take those ideas from Reactive Manifesto and see how they fall into place. Play allows us to build responsive web application. Play has constructs like WebSocket, server-side events, using which you can build interactive apps where you can engage your customers. And Akka, on the other hand, gives us event-driven, scalable, and resilience. In this webinar, we'll focus on this area. So what is event-driven, which is now changed to message-driven? Why should somebody do event-driven or message-driven architecture? The basic reason for that is a decoupled design, where in this design, your sender has no knowledge about who's going to consume the message. The benefit of this decoupling, this separation, is that it provides flexibility, using which you can scale out. You can replace the consumer with something else if you have to. It provides this flexibility, and we will see this in action, how it allows us to evolve architecture in Akka. The way Akka provides us to build a message-driven application is called actor programming model. So what is actor programming model? Actor programming model is actor is a computational model. It provides three features. Processing, that means it can do some stuff. It can do your computation. It can do the work. It can hold a storage, essentially a state. It could be your application state or state that you're accumulating while your application is running. And finally, actors know how to do communication. So actors know how to talk to each other. These three basic features of actor model makes this three axiom. What is that? When an actor receives a message, one way to think about actor, it almost feels like if I change the definition of an actor with an object, you would feel like, okay, that actually makes sense. It also looks like an object. The fundamental difference here is actors are much more lazy. They are not active. What do I mean by that? I mean that actors by itself will not do anything unless you tell actor to do something, like send a message. Okay? And second fundamental difference here with actor programming model is that communication happens completely asynchronous. So what can actor do if we follow the guidelines of actor programming model? What can actor do when it receives a message? Well, it can create new actors. This is a very useful feature. For an example, let's say I give you a work to do, okay? Here, find flights for me. Then you can take this large work, split it into smaller tasks, and fan out, send it to your small or other new actors. Create new actors and send message to that. It's a perfect example of doing map reduce, for an example. Second thing it can do is that it can send message to actors it knows. Okay? And third, which is a very interesting feature of an actor programming model, is to decide what to do when the next message will come. So this kind of gives an indication that when you use actor model to build your application in general is evolving. So for an example, when you receive a message, you say, I receive a message, I want to be something else, like you're building a finite state machine. Actor model is perfectly suited for that. You can change the behavior. Now let's see some code. I think it's a good time to see an example. Now let's say I have a flight booking actor. Okay, this is just an introduction, a warm-up we're going to do to see how it looks code. So when you typically create an actor, first thing we do is that we create an object. We call it a companion object for that actor. In this case, I have an actor called flight booking. This actor has a factory method. This is a very common best practice people use. This is considered as a best practice. That here, props is essentially a factory. Props knows how to create a new instance of an actor. In this case, I'm saying, hey, to create an actor, you have to do new flight booking. And companion object actor also does something, which is define message protocol. What do I mean by message protocol? Message protocol essentially is that what type of messages does this actor handle? What type of messages I can send to this actor? A home, a place where you can collect all the messages together. And finally, if you want to create an actor, you have to extend an actor trait. Now, do you remember what we talked about in actor model? The actor model is the computational model. It provides three properties. Okay? Storage state, your application state, like counter or deals or how many flights you have booked so far, any state that accumulates while your application is running. Now, this is very interesting that I have declared a mutable state here. That means state that can change over time. Now, we all know who have dipped or played with concurrent programming that mutable state is essentially a bad idea. But one of the biggest benefit of actor programming model in Akka is Akka makes sure, Akka runtime will make sure at a given point of time, your actor instance can handle only one message at a time. What that means is that it's actually safe to use mutable state. In fact, I will go into a stretch and say that if you have a mutable state, actor model really shines. So you have an example of storage here, then another, and we also talked about processing. Processing is where you actually implement the behavior. In this case, to implement a behavior, we overrode a method called receive, and I'm handling that make new booking message. We are using Scala's pattern matching here to unpack the case class. Now, this is another interesting thing to remember. It's okay to have mutable state inside actor, but all the messages that you send between actor, the messages that actor use to communicate with each other has to be immutable. So in this case, we are handling the make new booking message, and finally, we are booking the flight and actually using another communication. That means I'm talking to an actor I know, saying payment gateway, hey, charge my credit card. So how do you create an instance of new actor? What do you need to do for that? Well, first thing you need to do is create something called, oops, I jumped quickly. Okay, first thing you need to do is create an actor system. Actor system, think of an actor system without going too much of details. Think about an actor system as a context, as a runtime that provides services to you. Okay, all the services we'll take a look at, like resilience, like supervision, like resources, dispatcher, all this stuff that provides the actor system. Once the actor system is created, you can actually use a method called actor_of to create an instance of actor. Once you have an instance of an actor, using you actually never get the actual reference to the actor. What you get is a pointer. We can think of as a pointer. A proxy, we call it an actor ref. This actor ref knows how to communicate, how to send messages to actor. Once you have an actor ref, then you can start sending messages. To send messages, you have this exclamation method. We call it tail or fire and forget. In this case, I have a booking reference actor, and I'm sending a make new booking message. This is a fire and forget. That means this message will be sent, and I will get the control back immediately, because these are all asynchronous and non-blocking. I think it's a good time to take an example to tie all these concepts together. Let's say we are trying to build a find cheapest flight application. Okay, this is a new startup that we are building. What we do here is that we allow our customers to find cheapest trip. Right now, this application is running in 3 countries. We are running in Germany, we are running in UK, and we are running in US. So when somebody sends a flight search, what we do, we decide based on which city the customer wants to go, we decide which of these services should I use or components should I use. And each of these components essentially talks to a list of providers. It could be your booking.com, it could be cheapflights.com, whatever. Okay? And once we get all the offers back from each of the provider, this component kind of decides which is the cheapest offer, and we send the cheapest offer back to the center. Simple enough? Now let's see how we can solve this problem if you want to use Akka, an actor programming model. So we're going to gradually try to build this application. All right, so first part. Now, first thing we're going to do is that we will try to create something called flight search actor, right? We'll take that box and we'll make a flight search actor. What flight search actor will do is that whenever it will get a message, we need to do a work. We need to figure out which country, which component should I use, okay? So that means I need to have some sort of routing mechanism. Okay, routing is one thing. The second problem I need to solve here is, since each of these components, since we are a startup, we are trying to give lots of discount, each of these components could have specific country-specific discounts. So I want some sort of routing logic where same type of messages could be routed to the same component. So consistent hashing, when I get a message, if I can use a consistent hashing mechanism to figure out which component should I route the message to, my problem is solved. Because benefit of this is that whenever message, let's say we are getting lots of search for Berlin, then if I can always route those messages to the component who knows how to handle Germany, then I can have warm cache, I could cache deals, I could cache offers, lots of interesting things we could do as an optimization technique. So in this case, what we're going to do is that obviously we're going to build a flight search actor. We're going to use a consistent hashing router that comes with Akka out of the box. What is router? Router, essentially, the name says it allows you to route messages to many an actor so that you don't go on your own. So let's take a look at the code. How are we going to implement this? Obviously, going to again start with the companion object. Here we have a flight search companion object where we are deciding which message we're going to handle. In this case, is a flight trip message from and to city, start and ended. Simple enough. And we have a factory method which is going to create the actor. Now let's look at the interesting bit, which is the implementation of an actor. Hold on. All right, so implementation of actor. What are we doing here? The first thing we are doing here is creating our router. Same actor of concept here. We are saying, hey, Akka, please create a consistent hashing. The difference, the reason we say pool, that means I'm not going to bother creating those actor instances that we saw in the previous slide here. All I'm going to say is that, hey, consistent hashing pool, create 4 actors for me. By the way, the hashing mechanism is by country. This is a method that I have implemented. And here is the factory that you could use, which is search worker.props factory to create those instances for me. So with that single line, we would achieve this. Let me go back a little bit. This thing right here. Now let's see what's happening in the processing. What's the processing looks like? Well, whenever we get a fine trip message now by some sender or some customer is requesting for a trip, what we do is that we forward the message to the router, saying find the cheapest flight from to and find the cheapest return flight for me. I did forward here. What that means is exactly what essentially it means. That means whoever sending the message, I'm forwarding the message to search worker. So when search worker is done, it can directly reply back to the sender so that I don't have to be bothered with this. Now let's build the next part. So we managed to send message to our search worker. Now what search worker will do? Well, first thing the search worker needs to do now is it has to go through all the providers it knows. Let's continue the example of Germany here. So somebody is trying to go to Berlin, and this German component here, Germany, which handles Germany, will find all the providers that services Germany and needs to send broadcast message to all of them. Now to do that, Akka also has a nice tool called broadcast router. So we're going to use a broadcast router which is already built in to broadcast messages to all the provider. Let's see how that looks right now in code. We're going to start with the same thing again. You see a theme, you see a pattern here, right? So we're going to define the message. Here the message is find cheapest flight, and we also have a factory to create that worker. Now in this code, like I mentioned, the reason we were using consistent hashing because we are accumulating state here. We are caching things. We are keeping track of how many deals we have sold so far. We are keeping track of what kind of discounts I can offer to the customer. And this guy also creates an router, but in this case, I'm creating a broadcast group router. The basic difference between group and pool is actually not very important in this concept, but again, the group means I am creating the instance of an actor. Here you go list of providers. All you have to do is now broadcast messages to them. So difference between pool router and group router is essentially who is creating instances. Now the receive block also looks very simple where whenever somebody sends a find cheapest flight, we go to our router and say, okay, find flight. So this message will be going to all the providers that I have in my list. Now here is a tricky bit. The tricky bit is once all the providers comes back with the response, obviously everybody is going to come back with, here is my offer. I can give you Berlin flight for 150 euro, or somebody could come with 120 euro. We need someone to listen to all the messages and kind of aggregate. In this case, what I'm doing is I'm creating a child actor every time I'm receiving a message. Now, this is something interesting to think about for an example. you might be thinking, is that costly, creating child actor every time someone sends a message? Actually, it's not. In fact, it's encouraged. Akka are so lightweight, they take around 300 bytes in memory, that you can create millions of them. And since they're so cheap to create, it allows you to implement complex logic very simply. For an example, what I'm doing here is that I'm saying, hey, if whenever I'm getting a find cheapest flight message, I'm creating a find cheapest deal actor whose sole purpose is, it's almost like, say, I'm single responsibility principle here. His sole purpose is to aggregate those responses and find the cheapest offer for me. And another difference you will notice, which is intentional, instead of using that bang operator or bang method to send the message, I'm actually using something called tail, which is essentially alias, but tails allows me to do one extra thing easily. What is that? That is when I'm sending a message to proxy saying, hey, providers, find flight for me. And by the way, when you are done, please send the response to this guy out here, not to me. So this is a benefit of having a decoupled design. This is a benefit of building event-driven architecture, that I can switch between sender and provider because there is no hard link here. And finally, the job of the provider proxy is to send all the offers to cheapest deal finder, the actor we just saw now, and this guy will find the cheapest offer and finally reply back to the sender. We just closed the loop now. If you look at the code here, it's quite simple. Provider proxy declares a couple of messages, which is find flight, and flight details is something that it replies back to. And implementation is something like this, where whenever it gets a flight message, which is a processing of this actor, it searches for the flight, it finds the price, and it replies back to the sender. Who is the sender here? The sender is the cheapest deal finder actor. Because remember, when we use the tail method, we switch the sender. I know it was a naive example, but if you think about it, we just implemented find cheapest flight flow with just few lines of Akka code. One of the interesting things I noticed when helping teams with Akka or building Akka application is that essentially when you have applications like this, first thing you do is whiteboard, right? You go to whiteboard with your team, you discuss, you draw boxes and circles. Since Akka provides this nice abstraction and actor programming model is so nice, you can almost literally take those boxes and circles and implement in your code like an identical way. Very less friction that way. Now there is one very important aspect I'm completely ignoring here. What is that? That is, what if something goes wrong right here? Obviously, I'm calling provider proxy, which will essentially make some remote call to the provider side, some remote API to get the flight details. I mean, there are lots of things could go wrong. That endpoint could be down, the network failures, there are many things that could go wrong. So how can we handle this? Right? If provider endpoint goes down, you just cannot say that, okay, the cheapest flight search application is not working anymore just because some provider is not working. The way Akka solves this problem is something we call let it crash. Now, if you think about it, for many years now, we typically do defensive programming. We are used to defensive programming because we know things will go wrong, and what we try to do is that we try to put preventive measures. So that means we become very defensive. For example, we'll try to say, okay, let's check all the given input parameters. Let's try to catch all possible exceptions we can so that our application doesn't crash in production. But it always does, isn't it? Things always go wrong. Now this latest crash is completely framing the discussion differently now. It's saying, no, let's not get scared about the failure. How about we do this? How about we say failure is just another state in your application? Things going to happen, okay? Instead of worrying about it, instead of being defensive about it, how about we think about how we can recover from the failure? We will assume things will go wrong, but now let's talk about how we can recover from it. Because when you start thinking in this way, there are lots of interesting design things we could do here. We know that if you want to build reactive application, you have to be resilient. You have to have uptime. People these days, everybody expects your application is up. If your application is down, it's bad for business. You lose money. So what is resilient means here? Resiliency, when Reactive Manifesto talks about resilience, it's actually talking about, hey, embrace the failure. It's a natural state in app lifecycle. Everything's going to go wrong. Okay? And what we have to start thinking about it is not as the end of the application, not just going before the production. We should thinking about resiliency as part of the design when you're designing the application. We need to start having conversation right then that how can we handle failures. Failure should be detected, should be isolated, because we really don't want a subsystem crashing, taking the entire application down. So what does that mean in this naive small example? So let's say we have this provider proxy. Where can things go wrong? There are many places things could go wrong, but let's take this particular example where our provider proxy is trying to make a remote connection to provider endpoint, making an API call. Well, there could be network down or we don't get a response, so something could go wrong here. And typically, if you don't consider failure here, in typical application, what happens is that your something blows up and you get a huge exception stack trace. And if you're unlucky, that could take your entire application down. I think it will be easier if we take a real-world analogy, because I think we all kind of been into that position here. That is struggling with vending machine. We all have been there, right? We put coin in, nothing works. So let's see how vending machine, right? You are a programmer, you walk into the office, you need a coffee. So first thing you do is that you go to your coffee machine, insert your coin. It might ask you to insert more. And then you finally get the coffee. This is the happy path when you're having a really good day, right? But when the days like this where, for an example, you insert coin and it says out of coffee beans. Now that is wrong. Because you're looking at it, you say out of coffee, you have no idea how to fix this. You never filled coffee before, you have no idea how to open the machine, you are just very upset right now. Now if real world a vending machine works like this, then it not be very successful, right? What real world vending machine instead do typically here in this cases is when you insert a coin, it doesn't tell you that coffee beans are out to you because you have no idea how to fix it. Instead, it sends the message to someone who's supervising the machine. It could be the floor manager, it could be the company, I don't know, somebody who knows how this machine works, who have access to coffee beans and fill up coffee to this. So finally, you can get the message. You can get your coffee, you can start your day. That's how it should work. So what's the general idea? The right way to build something like this is a classic failure scenario, right? Something's going wrong in production. Something going wrong when you deploy your application. The right way to do this is like this. If you're a client, you're calling a service, you send a request, and it gives you a response back. And if something goes wrong, like validation, for an example, or I didn't provide the city, or I didn't provide the date when I'm looking for a flight, it can come back with an error, hey, you're missing a date field, or you didn't specify the time, you didn't specify the city. Okay, validation errors. It's fine to send validation errors to client because client knows how to fix it. But if there is an application error, like something blowed up or the network is not working, in that case, we need to have someone else do that. Now, this thing is nothing new. This is very interesting because actor programming model very much resembles how the real-world organization works. Like in real-world organizations, you have managers, you have subordinates. If a subordinate falls sick or subordinate is not doing its work, it's manager's responsibility to make sure that that problem is fixed. So there is a supervision. You need to have a supervision model like this, a supervisor model that supervises actors and makes sure that that system is running, system is kicking. Another way we describe this is self-healing system. That how can we heal from failure? So what that means to our tiny application, it means that if a provider proxy gets an error, for some reason the endpoint is down, it should send the exception to some provider supervisor, some actor that we need to build in our application, which could decide many things. It could say, that provider is blacklisted, it's crashing very often, I'm going to blacklist that provider. Or it could do retries, or it could resend the message. Now, since we are framing the discussion differently, now see how many interesting possibilities we have. So if you truly believe in building reactive, scalable application, resiliency is a very important thing to consider, a very important feature to have. And on the core level, it's fundamentally important to isolate failures. You need to make sure failures are isolated so it doesn't affect the rest of the system. I want to do a quick recap now of what we have discussed so far. So Akka is an enabler for reactive application. We have seen this slide at the beginning of the presentation, but I think now the slide will probably make more sense. Okay, it provides individual entities, which is your actor model. Okay, actor model is your abstraction, is that building block which helps you to build these applications. It provides this excellent isolation of mutable state. We talked about that actor could have application state inside it. And yes, sometimes it can change, and that's okay, because Akka will make sure that at a given point of time, only one message is passed to you, so it's single-threaded. Location transparency. We just saw an example. With only very few lines of code, we were able to scale up. Right? We had a router, we had a multiple instances of worker running. So technically they are already concurrent and parallel. They're taking benefit of all the resources that you have available. But Akka also provides location transparency. That means all the boxes that we just saw, workers and providers, we can take them during deployment and say, I want to scale out. I want to have these providers or workers run on different machines. And you can do that. It's just a configuration. We also talked about supervision, how it's important, how Akka uses supervision, using parental supervision. That means is the actor which creates a child actor, so the parent is responsible for supervising its children, like in real world. If you were a little bit excited about Akka after listening to this, I would really encourage you guys to take a look at all the activator templates that we have. When you have activator templates of learning how supervision works, you have activator templates for routers, clustering. I would definitely encourage you guys to play with it. I think I want to take some questions now.
All right, thanks, Nilanjan. That was great. If you have questions for Nilanjan, please submit those into the chat box. Nilanjan, would you mind just going into a little bit more detail, though, about what specifically Activator is, if folks aren't familiar with it?
Okay. Yeah, we'll try. So Activator is a bootstrapping mechanism. It's a tool that we have that allows you to learn. There are lots of new things out there. I was looking at the poll. There are lots of there was lots of no answers in terms of have you used Akka before or are you using Akka in production. Especially this tool is meant for people who are new to this technology but interested about learning. They want to know example for how can I use Scala to do this, or how can I use Akka to solve this specific problem. So Activator is this tool set that we have created using which we deliver templates, examples, code examples, using which you can create projects or bootstrap your team as quickly as possible.
Okay, yeah, that's helpful. Thank you, Nilanjan. A couple of folks were just commenting about the varying degrees of Activator template quality, and maybe Nilanjan can speak to it more than I can, but I know that's something that the Activator team is working on, just to make it a little easier to understand kind of what the more comprehensive and the templates that pass certain tests are. So I know that's definitely something that's going to be happening down the road. All right, let's hop into the Q&A. So, Nilanjan, first question, with multiple play servers and a single Akka master server with failover, is there a concern of a single point of contention for messaging, and how might that scale?
No, I mean, so obviously if you want to build a resilient application, you need to have a replication at some point. So that's why that figure had a failover Akka server. But the sending messages and remember the way we did that reference architecture is what master is essentially doing is distributing work. If I can think of this master as a router for an example, let's say it's a broadcast router or consistent hashing routers. Routers are really fast. In fact, router is a specialized kind of actor where you don't even pay the cost of putting the message in the mailbox. It's smart enough to take the message that you send and immediately forward to that router. So it actually doesn't affect any scalability problems or doesn't introduce any scalability problems.
Okay, cool. Next question, what's the advantage of spawning the child actor for every search request?
Actually, simplification. The reason, so let's take this concrete example where I was doing the aggregation. If I had to do the aggregation in the worker actor itself, my logic would have been very complicated. So what I essentially did is use a single responsibility principle essentially. That's saying, okay, I want my actors to do one job and one job very well. And it's actually very recommended practice too, because since actors are so cheap, why not, right? So you have the small actors doing one thing and one thing very well. The benefit of that is if that actor crashes, then supervision also becomes very easy. Because remember, if you have an actor which is doing 5 things, the supervisions become very tricky. You might want to think, okay, for that message I want to recover this way, for this message I need to recover this way. So it's just to simplify the problem.
Okay, great. Can you talk a little bit about Typesafe console and how it could be made to work with Java? So you might want to just explain a little bit about what's happened with Typesafe console, Nilanjan.
Okay. So if you have, let's say, lots of interesting questions here. Okay. I hope I'm answering them right. If you're not satisfied, shoot me email to Laura, and we will try to figure out a way to answer it better. So Typesafe console. Okay, so Typesafe console is part of Activator now. I mean, if you download an Activator, again, there is another reason why you should download Activator is that when you're developing using Activator, because Activator just becomes a build tool, an environment using which we're getting the feedback, you can also get into and inspect your actor system, your queues, your messages. But this is where the thing stops, because Activator is a development tool. You essentially don't use Activator and deploy Activator in production. But for production monitoring, we recommend the partners we have like AppDynamics, New Relics, and those tools are recommended to use because really we are not in a monitoring tool business. So.
Great, thanks, Nilanjan.
I hope that. Okay.
Yeah. No, I think that was. The person had also asked. There was a second part to his question about how it can be made to work with Java, but I think that was kind of addressed in your response.
Okay. Yeah.
Next question, and like Nilanjan said, there's a ton of questions here, so we're going to do our best to get through them. We have about 10 more minutes left, but if we don't answer your question, we will make sure to follow up with you via email. And I think I mentioned at the beginning of the webinar that we will plan to post a blog post where we highlight the questions and then hope we can share the responses so that everybody can benefit from the knowledge. So next question. In the client-server model, is the supervisor playing the role of the actor?
Can you ask me one more time? Sorry, I didn't get it.
Sure. In the client-server model, is the supervisor playing the role of the actor?
So supervisor, I wish I had a code example. The reason I didn't do that because I thought it might confuse people. But no, supervisor is just another actor. Well, let me highlight this point. Maybe I was not very clear. So one of the things happens, I mean, you guys will all realize that once you start building application using actors, actors by nature itself forms a hierarchy. So classic way to look at how actor-based application architecture looks like is look at how a typical organization works. An organization has departments, departments have managers, managers have subordinates, and exactly if you build an application using actors, actors also forms this kind of a hierarchy. You have a parent, parent's going to have a child, because typically we do, like I said, we build small actors and they do only one thing. So in our case where we had like the flight search actor, the one that gets the first request and fanning out to all the workers, in that case the flight search actor was the parent of all the worker. The reason this hierarchy is important because in Akka by default, the actor that creates the child actor becomes a supervisor automatically. So a parent actor, the actor that creates a child actor, that parent actor will do the supervision. So the one way to talk about this is that an actor supervision is a parental supervision. So as a thing, first of all, Akka comes with the default supervision. Even if you don't do anything, okay, you don't even do specific thing about resiliency, actors will automatically, Akka automatically provides supervision. But the default behavior is if an actor crashes, it automatically going to restart your actor. So you don't have to, what I'm trying to say in summary is that it's not a special thing, it's just another actor in your application.
Great, Nilanjan, I think that was helpful. Moving on to the next question, what are the other let it crash approaches beyond just a retry?
Now this is a very application. I mean, it depends on what type of application you are building. Right? Retry makes common sense. There's lots of times it uses that. And another could be stopping it. In some cases where if you see an actor crashed and there is no way to make sure that actor could be started again, you could stop it. There is a supervision called restart. That means if an actor crashes, it's going to start a new version of that actor or a new instance of an actor. There's something called resume also. So for an example, if an actor crashes, as a supervisor, you could say, let's keep that actor going. That's okay. We can ignore this exception. These are all something built in. But again, like I said, you're free to do. This is your space. You can be as much as creative as you want.
Okay. What is the difference of a supervisor and a container as EJB container?
I'm not expert in EJB. I'm not sure whether EJB containers provide supervision. The container, in a sense, if I'm understanding your question correctly, you mean some container in this case provides set of services. But supervision I'm talking about is when you call somebody a method. Let's simplify this problem so that we can understand. I mean, there are lots of supervision questions. I'm very glad about it because I'm glad that people are interested in this area. So let's say what happens in typical Java or Scala application, typical, that you call a method like go to the endpoint and find a flight offer for me. Okay, you make a REST call to a method. And if that method blows up, what happens? Exception bubbles to the call stack. That means you as a caller are going to get an exception. We personally think that's a problem. Why? Because obviously we see lots of empty cache boxes in production code. Because as a client at that point, you might not have all the information or context, or maybe you're not the right person to decide what to do with that exception. So you either catch it, do empty, you say, I don't know any idea, or you bubble up to the call stack. Whereas in Akka, the exception doesn't bubble up through the call stack. It bubbles up through the parental hierarchy. So as an actor, if I call find me an offer, I send a message, and that provider proxy actor crashes, it will not give me the exception back. It will bubble the exception to the parent. It will say, parent, help me out, what to do here? I just got an exception. So it's a completely different way to handle resilience. It's a completely different way the exception flows in this kind of systems.
Cool. Let's see. I'm just trying to pull out some questions here that would be good for everyone to hear since there are so many of them. Nilanjan, if you're reading through them, feel free to call out any that you'd like to address.
Yeah, okay.
So let's take this one. So an enterprise system that's built on the actor model, does it have to begin with creating all the actors, which are part of the error kernel? And if we are to say doing transaction processing, does it mean we could create an actor to process each transaction?
Yes, I mean, I guess you could do that. In fact, maybe I will do that too. I'll create an actor so that I can have that isolation. And you mentioned error kernel pattern. Yes, that's another reason which triggers people use child actors. So let's say you are an actor where in an actor you're holding some important state. Like we had in our search worker, we are holding cache deals, counters, all the information that are very critical for our application to run. I would not have that actor perform any risky operations. In cases like that, people use error kernel pattern where they take that risky work and offload to a child actor. Because hey, if something goes wrong, all that happen with the child actor will crash, but I will still have the state. So yes, so it's very much recommended to spawn new child actors. So there is a question. The last question I'm looking at is okay. Let's take last two questions here. Can we discuss actor debugging strategies by Sassy here, Lucas? It's a difficult question to answer. Yes, debugging is tricky in message-driven application because we have this asynchronicity, non-blocking. You need to track. But I don't know whether you have seen this presentation by Julian. Maybe we can post that when we create the notes with the list. Is we have somebody in Typesafe actually working async debugger. What that means is that when you're debugging actor-based application, it's going to follow the message as it flows through. It bounces from one actor mailbox to another actor mailbox. We realize we need some tools to help out here. But if you want to know how Akka team debug Akka applications, they use printlns. Let's take the next one. There was a question here about STM. It's easy to answer, but essentially I don't know. I don't see STM getting put back into Akka because we have some reservations around it, and I don't know. Maybe you can send me a mail later. Maybe give us a context because we are still looking for examples out there, a large-scale example of STM implementation and how that's working.
Yeah, Nilanjan, maybe it makes sense for you to just follow up with this individual via email. I can make sure you are put in touch.
Okay.
All right, guys. Well, I think we are about out of time now, so I just wanted to wrap up. One thing I wanted to mention before we all hop off is that if you're interested in learning more about how Typesafe can help you with future projects, you're working on an Akka or Scala project, I do encourage you to look into the Typesafe subscription. The subscription offers certified builds and professional maintenance support and other perks. You get to have access to experts like Nilanjan and really the core creators of the projects themselves. So it's really worth looking into. You can visit Typesafe/how. I can post that URL into the chat box so you can take a look. And thank you for joining us for the webinar. And if you missed the previous two sessions on just the general overview and then also the one on Play Framework and Activator, we will be publishing those links shortly. We'll make sure everyone has the slides. And hopefully you got a lot out of the series. And if you have advice for future webinars, stuff that you'd like to hear, please don't hesitate to reach out to me. My email is laura.masterson@typesafe.com. And with that, I just wanted to thank Nilanjan for presenting, and hope everyone has a good day.
Yeah, bye.